Alright, let's get started with our unit test for the differentiation, definition and basic derivative rules under the course calculus. Let's go. For the first question, they have asked us to find the f prime x, which is we have to differentiate the entire fx. So 5 times 3 is 15, x squared negative. Now, the differentiation of cos x is negative sine x, so this becomes positive 6 sine x. So this is our answer. Okay, so we take this thing, multiply with 5 3s are 15, and we reduce it with 1, 2. The differentiation of cos x is negative sine x. Negative negative becomes positive, and 6 sine x. What is the value of h prime 16? Well, again, we first find the differentiated value, so it's 1 by 4 and 1 by 4 multiplied by x, so x, and we reduce it with 1, so to the power 1 by 4 minus 1. This is the differentiated value. So we take this 1 here, multiply it 1 by 4, reduce it with 1, and we plug in 16 in order to find the differentiated value, which is this value. We have to insert this value. So this value could have been written as 1 upon 32 because they want the answer, should be in a proper fraction. So we don't want to insert decimals there and insert 1 upon 32. There we go. F is function of its graph. The dashed line represents asymptotes, as you can see. Select all x values for which h is not differentiable. It's not differentiable. First of all, it is x equals to 2 because it has a sharp turn. What about x equals to minus 1? X equals to minus 1 has a value. No, it's differentiable. What about x equals to 0? X equals to 0, the same thing. It is differentiable. 2 and x equals to 3. But if x equals to 3, it is differentiable. In fact, the differentiation is 0, so only 2. The following table lists the values of the function f and h and of their derivatives f prime and h prime for x equals to negative 1. We have to calculate d by dx fx times hx. Basically, it's product rule. So what we have to do is, when we multiply a function with another one and find the derivative, so fx times h prime x plus f prime x times hx, and we have to find f minus 1 now. Fx minus 1 is negative 3 times h prime minus 1 is positive 3 plus f prime 1 into h, which is negative 4. It's negative 9, negative 4, negative 13. It's negative 13. Let's confirm this. We have a calculator, so negative 3 times 3, positive 1 times negative 4. Negative 13. We have to differentiate this thing, but in order to, before we do so, we have to move this on the numerator. So x to the power negative 4 positive x to the power negative 2 negative x cubed. So differentiating this becomes negative 4 x to the power negative 5, because we subtract 1 to get x to the power negative 5, negative 2 x to the power negative 3 negative x 3x squared. So negative 4 comes here, we reduce it 1, negative 5, negative 2 comes here, reduce it with 1, negative 3, and 3 comes here, negative 3, reduce it 1, because 3x squared. So 4 x to the power negative 5, negative 4 x to the power negative 5, negative 4 x to the power negative 5, negative 2 x to the negative 2 x to the power negative 3 x to the power negative 3, negative 3x squared. Negative 3x squared. Negative 4x over negative 5, negative 2x over negative 3, negative 3x squared. Okay. Nate, pardon, try to find the derivative of 5x minus 1 using basic differentiation rules. Here's the work. So basically d by dx, and we distribute the d by dx with this. So differentiation of a constant is 0. D by dx 5x, 5 move it there. We have 5. And yeah, the person is correct. Differentiation of 5x minus 1 is indeed 5. So no mistake at all. What about this? Differentiation of 3 to the power ex is 3 to the power ex. And differentiation of 5x squared is 10x. Because you multiply 5 with 2, it's 10, and you reduce this with 1, so x. And we can, so this is the final answer. Okay, so for this one we need the quotient rule. I'm going to differentiate this. Denominator square, x squared plus 3x. So this is u, this is v, v square. V times differentiation of this, which is negative 3. The differentiation of this is 0, and negative 3x is negative 3, minus u. Differentiation of b. When I differentiate this is 2x, and this is 3. So v square, v, differentiation of u, negative u, 5 minus 3x, differentiation of v. This is our answer, but we have to simplify it. So if you multiply it with the, negative 3, we have negative 3x squared, negative 9x. And negative. Okay, why do you have to differentiate? Why do you have to simplify? I don't understand. I can plug in right like this. Any issues? We just have to have a bracket there, because negative 3x squared, negative 3 3s are 9x, so negative 3x squared, negative 9x, negative 3x squared, negative 9x, and then we have subtraction with 2 multiplication. 5 minus 3x, 2x plus 3. In the denominator, x squared plus 3x squared. There we go. Estimate f prime 5. So we have to differentiate this to get 5. Okay, we don't have any equations. Definitely is not 0. How do we find the gradient at this point? We take a tangent. We take a tangent to this point. So let's say this point and this point, maybe something like this. Maybe, I don't know. This is an estimate, of course. So this is y2 minus y1, 8 minus 3, x2 minus x1, 7 minus 4. It's 1.6. So it's positive 2 basically, because negative 2, it's a positive gradient. As x increases, y increases, so negative cannot be. It's definitely not 0. Now we're left with either 0.1 or 2, so it's 2. fx is this function. What is f prime x? Okay, again uv. V would get squared, so it's ln x squared. V, differentiation of u minus u, differentiation of v, which is 1 by x. This gets cancelled out. We have 2x ln x minus x. And we can also take out x common to get 2 ln x minus 1 into x, or 2x ln x minus x. This is correct. Alright. The following table lists the value of function g and h and of their derivatives g prime and h prime for x equals to negative 2. Let function be defined as fx equals to this thing. What is this thing? F prime negative 2. Basically, we have to differentiate this thing. We have to find the d by dx of this thing and then plug negative to that. So, how do you do this? How do we do this? Well, it's just 6g prime plus 2 h prime. And when we differentiate a constant, is 0, so basically this thing. So f minus 2, so 6 times g prime, so it's 2. Positive 2 times h prime is 8. So 6 times g prime, 6 times 2 plus 2 into h prime, which is 8. 6 into 2 plus 2 into 8. $64. 6 into 2 plus 2 into 8. 64. So we don't need the values for g and h themselves. No, we don't need that. What is the issue? What is the issue? Six times 2. Oh no, this is a super silly mistake. Six times 2. Oh no, 28. Everything is the same. You know, it was 6 times 2. I just plugged in 6 times 8. So it's typing mistake. 28. Okay. This table gives silly values of differentiable function f. What is the base estimate for f prime 2? We can make based on this table. What is 2 basically? Best estimate on this table, 2 is here. So if you try to find the gradient, let's say this is x2. So y2 minus y1, negative 33, positive 25. y2 minus y1, x2 minus x1, 4 minus 1. We have negative 2 point something, so it's negative this thing. Yeah. So differentiation of h and 0. So sec is 1 upon cos. 1 upon cos. And how do we differentiate this? Well, quotient rule. Cos square x. Cos x times differentiation of 1 is 0. So 0 minus 1 into differentiation of causes negative sign. So we're left with positive sine x upon cos square x. And if you plug in 0 here, sine 0 is just 0. So anything divided by 0 is also 0. So this is our answer. But we want to check this. If you want to check this, let's see what Desmos gives. 0. Yep. So let g be a function such that g4 equals 16 and g prime 4 equals 12. Let h be the function hx equals to root x. Let h be the function divided as, you know, this thing. How do you find the differentiated version of this? Basically, if you want to differentiate this thing, it's quotient rule. So it's hx squared hx differentiation of g, which is g prime x, minus gx differentiation of hx, which is h prime x. hx squared v squared hx times gx prime g prime x minus gx into differentiation of v, which is h prime x. Now we know that h prime x would be half x to the power minus half, or 1 upon 2 root x, because negative half means 2 is there, and half means basically root. So how does that work? hx, we need 4. h4, we have h4, we can plug in h4, so it's 2. So let's use a different color. So if we plug in 4 here, it's 2. g prime, here we have 12, minus gx 16 minus times h prime 4. So what do we get here if we plug in 4? 1 upon 2 into 2. 2 to the 4, 1 by 4. It's 1 by 4. Okay. Root 4 is 2. 2 into 2, 4. And hx squared. So hx is 2. So 2 squared is 4. Now we have to calculate this. 2 into 12 minus 16 into 1 by 4 and divided by 2 square is 5. So answer should be 5. Okay, differentiation of this value. So basically this thing gets here multiplied with negative 10 x to the power 4. This thing gets multiplied with here, so it's negative 9. Negative 9 x squared, and this thing becomes 0. So negative 10 x to the power 4 5 2s are 10, negative 10 x to the power 4, negative 9 x to the power 2. Okay, negative 9 x to the power 2. That's it. And the differentiation of this constant is 0. Is the function below continuous, differentiable? Okay, let's first find whether it is continuous at all, at this value or not. So we have x squared plus 1, and we have to plug in x squared plus 2x. When x equals to 1, we do get a value here. So it's something like 3, yeah. And 4x minus 1, x equals to 1 is something like the same value, basically 3. So 1 3, yeah, it is continuous. Is it differentiable? Let's find the derivative. The derivative of this is 2x plus 2. The derivative of this is 4. Okay, so if you plug 1 here, 2 into 1, 2 plus 2, it's 4. Both have the same differentiation. Here, both derivative leads to same differentiated values. So yes, it is both continuous and differentiable. Okay, so it's 11 x to the power 10. Basically 11 gets multiplied with this and 10 gets reduced by 1. Write an equation of the tangent of line tangent to the graph of this at the point where x equals to -2. We need equation of a line that is tangent, so we need the f prime. So 3 is 9x squared plus 8 2s are 16x. Okay, 3 gets multiplied by 3, we have 9. This gets reduced by 1, x squared plus 8 2 that is 16. This gets reduced to 1. And we have to plug in now f prime minus 2. So 9 into -2 squared. Positive 16 times -2. So 9 into -2 squared, 9 into -2 squared, plus 16 times -2 is 4. And what about -2 here? Because we need a point. This is the gradient of the slope, m equals to 4. In order to find the equation of the tangent, we need y minus y1 equals m x minus x1. We got the m, which is 4. But what about point? We know that x equals to -2. We also need the value of y. So in order to do so, we plug in -2 here to get 8. So this, the point is 8. -2, 8. Now y minus y1, y minus 8. Equals m that we have got, which is 4. X minus x1, so x positive 2, because minus minus is positive. This is the equation. That's it. Okay, differentiation of this thing is a product rule. No, it's a quotient rule, because x is the same as cos x times x. So x squared, x times the differentiation of cos x, which is negative sine x, negative cos x. The differentiation of x is 1. So negative x sine x negative cos x upon x squared. As you can see, this matches exactly with option A. So this is our answer. What is the slope of the secant line that intersects the graph of this thing at 0 and 2? Well, we have to plug in 0 and 2 in order to see what is the values, what is the y values. So we have to plug in 0 and 2. So we find 0 and 2. So for 0 we get 1. So we have two coordinates here. 0, 1, and 2, 81. So when we plug in x equals to 0, we get 1. When we plug in x equals to 2, we get 81. Now all you have to do is find the slope. So it's y2 minus y1, 81 minus 80. 81 minus 1 is 80. y2 minus y1, x2 minus x1, 2 minus 0 is just 2, so it's 40. So what is the slope? Is 40. The tangent of the graph of g at the point this thing passes through this thing. Find g prime 9. Okay, let's see what it is talking about. Basically, we have to find the gradient. So y2 minus y1, 7 minus 2. x2 minus x1, 5 minus 9. Is negative 1.5 or negative 5 by 4. But let's see what they are talking about. The tangent line to the graph of the function. So let's say whatever graph we have a point. The tangent line is the tangent line of the graph function g at the point. This is the point. Passes through. This is the tangent line, passes through this thing. What is the what is the gradient at this point of the graph? q prime 9 is basically talking about the same. So the gradient of the graph at this point is the same as the gradient of the tangent, and you have 2 points of the tangent. We found the gradient of the tangent. That's why this would be equal to the gradient of the graph at this point. Which derivative is described with the following expression. Okay, so you have to check each of these now. So what is the formula? Well, it is fh plus t minus ft upon h as x tends to 0, h tends to 0 height. So you have a particular value here, you take a small increase in h, and then you calculate that value. So yeah. So if it is 0, so how does it work? Below we have h, obviously. We need to plug in root h plus t. So root h plus 0 minus 3, this is the positive one, minus root 0 minus 3. Okay, entire expression h plus t, so h plus t0, entire expression h is only 0, oh no, h minus 3. So what do we get actually? It's root h minus 3 minus 3, because this is 0, minus minus is plus actually. So we're only left with root h, but this doesn't match what we have here, so this can't be our answer. What about this? X plus 9. So we have h here, root h plus 9 minus root h, no, 9 plus 9. So we plugged in h plus t, h plus 9 here, h plus 9 and then 9 minus ft, so basically f9 here. So 9 plus 9. Again, this doesn't help because we need to get rid of this 9. If we can get rid of this 9, then like it would match as exactly here. Root 9 would become 3. So if we get rid of this 9, we're left with this option, and that's it. C is our answer. Last question. Differentiation of this value. So basically we can rewrite this as x to the power negative 6, and when we differentiate it is 6x to the power negative 7. This gets multiplied with this and it reduces by 1, negative 7, and just we have to plug 1 here. So 1 to the power anything is 1, so answer is just 1. But let's verify this. As you can see, it's negative 6. Negative 6 multiplied 1, so it's negative 6, and this is our answer. That's it. That marks the end of this unit test.